Hi, welcome back. Today we're going to talk about graphing and how we can use graphs to predict how much money we're going to spend. So I asked you to fill out a Google form, and some of you did this to think about this problem. So whether you thought about the Google form or not, just think about this question for another minute. Try to remember, what did you notice? What did you wonder? And what the problem was about. You can go ahead and pause it and come back when you're ready. All right, so rereading over this problem. This is about somebody going to the Kentucky State Fair, probably not this August, maybe summer 2021, they're planning. And they're trying to figure out how much money they're going to spend. So they see a graph and it shows how much 3 other people spent after doing 2 things. The first thing those people did was going through the main gate. So they had to pay an entrance fee just to get into the fair. And then the second thing those people did was buy some ride tickets. And that's where they could choose how many ride tickets to buy. And they also did let us know that every ride ticket is the same price right here. So let's get started with looking at what you noticed. I thought this was hilarious. People were noticing that for a state fair, this seemed like a really good deal. Like somebody could get in and buy 10 ride tickets and only spend $13. That sounds like a really good deal to me. So yeah, Los Angeles is expensive. Let's look at what these 3 people noticed. I'm just going to pull them out. And I want you to read over them for a second and think about what these 3 things have in common. So these 3 people were looking at the relationship between the 3 dots on the line. And what they noticed was that, of course, we can always label our axes in our graph, X and Y. And what they noticed is that as the value of X got bigger, going from like 1 to 9, the value of Y got bigger, going in between 8 and 9 all the way up to 12. So they noticed that there was a direct relationship between X and Y. When X was smaller, Y was smaller also. And when Y was bigger, X was bigger also. Let's look at 2 more. This person noticed if you take the first point and the third point, and you make a line going in between those 2 points, that line will also pass through the middle point right here. And then we have one more let's take a look at. Finally, someone shared with us that they noticed what the X and Y axis were representing, which is really important, and you'll see this next in your what you wondered. So you can just take another minute or 2 to pause it and read this one, and then we'll move on to what you wondered. Welcome back. So what you wondered, this really helped me know what you were thinking. Somebody said they wondered if the amount spent was in dollars. Now, when you're making a graph, it's really good to label specifically what something is being measured. So amount spent at the fair, it is in dollars. So as scientists and mathematicians, you should label that by putting parentheses here and putting a dollar sign so people know what unit it's being measured in. Somebody else said that they wondered why the first ticket spent cost so much money. So remember, going back to my intro today, we talked about how there's 2 types of tickets that the person is buying. First, they're buying their entrance fee to go through the main gate. And then next, they are buying their ride tickets. So knowing that first they had to pay to go through the main gate and then they bought ride tickets, we know there's 2 types of tickets and one could be more expensive than the other. So again, since you're going to be solving this problem on your own, I'm not going to give you the answer today. Remember that there's 2 types of tickets. there is the main gate fee, just to get in, and then there are ride tickets. So everybody, we are assuming, or I'm assuming at least, everybody buys one of these. They buy one main gate ticket. But the ride tickets are where there are differences. We see that somebody bought one ride ticket. We saw somebody else purchased 8. So it just depends on how many ride tickets that person purchased. Last but not least, this person says, I wonder when they say one ticket was purchased and the amount spent at the fair was 8.5. So that's a great question. What that means is that we had one main gate ticket purchased. So they got one main gate fee, plus they also got one ride ticket for $8.50. Let's move on to your predictions about what the problem is about, what it might be asking. So somebody said how much money they used for buying tickets. Maybe someone wants to predict how much 8 rides is going to cost, although I do already see that point on the graph. How much money would you spend if you had blank tickets purchased? So all of these are great answers. And for me, I would kind of break it down when you're thinking about this problem. See if you can solve 2 things. See if you can solve how much each ride ticket costs and how much the main gate ticket costs. Because remember, we talked about there's 2 different things you have to pay for. First, you have to go through the main gate and buy your ticket to get into the fair. Then you have to decide how many rides you're going to go on, and you have to buy your ride tickets. So see if you can figure out how much does each ride ticket cost and how much does the main gate ticket cost, and then see if you can notice how you solve that problem. I'm not going to share with you the problem solving strategies that you shared with me. Some of you gave me really great ideas about how you would start solving this problem, because I want everybody to get to think for themselves about how you would solve this problem. So we're going to go through another example that's similar to this problem, and then I want you to come back to this and see if you can solve either of these questions. How much is the main gate ticket, or how much does each ride ticket cost? So moving on to another example. This is how to graph a linear equation. So for example, let's say that I give my dog 4 treats a day. And then every time he goes on a walk, I give him an extra 2 treats. So this is 2 treats times the number of walks. So if he goes on 1 walk, he's going to get 2 treats extra. And then that's going to be added to the 4. So y is going to be the total number of treats that Quentin gets. He's been barking at me from the other room. So there's 5 parts to graphing this linear equation, and we're going to go through them with this example. There's the equation itself, and the equation is always going to be in the format y is equal to blank x plus b. And b actually is just another blank. So it's going to be like that. So you're going to have 2 different answers that fill in these blanks. You're going to have a number here, and that's the number that you're going to be multiplying by x. And then this is the number you're going to be adding. When you get into advanced math, when you're in algebra, they call this variable m, and this variable is always b, but you don't need to worry about that right now. But just for the future, you will see y equals mx plus b. So I've given you the equation, y equals 2x plus 4. Let's look at the second part out of the 5 parts. The y-intercept. The y-intercept, and I would write this down for you if I were you, it's very important. The y-intercept is where the line intercepts or hits the y-axis. And there's a really easy way to know where that is. If you write out y equals mx plus b, or y equals blank x plus blank, remembering that again, these are different variables. It's not the same thing on each blank. I mean, it could be, but it's usually different. To find where where the line is going to hit the y-axis, all we have to do, it's super easy, is look at this number right here. So in my example that I gave you of the number of treats Quentin gets is equal to 2 times the number of walks he goes on plus 4 treats. The y-intercept is equal to 4. And all that means is that when x is 0, y is going to equal 4. When Quentin gets 0 walks, he's going to get 4 treats. Another way you can look at it is like, here's a graph that I'm going to blow up of this y equals 2x plus 4. And you can see that this is the y-axis and that it hits the coordinate plane. It intersects the y-axis at the value of 4 right there. Okay, you're doing a great job. That's 2 out of 5 parts. Let's move on to part number 3. Part number 3 is the slope. So just like we learned to circle B, or the last blank space, or the 4 in my problem, to find the y-intercept, here, here, and here, there's something similar we can do for the slope. The slope is the number in front of x. So it's the one that is in this blank, or in this problem, it is 2. So when we have y equals 2x plus 4, the slope is the number that's being multiplied by the variable x. So it's how many treats Quentin gets per walk. Yes, I'm using an example about you, Quentin, because you won't be my video. Make sure you write all of this down. It's going to be really helpful for you as we move on to the last 2 steps. Okay, so the next part is to actually graph the equation. So I'm going to copy the equation down again. And then I'm going to make a table so that I can actually create my points to put on the coordinate plane. So I have x and y here, and I get to make up what the value of x is. So the first point that I'm going to do for x is I'm going to do 0. And so when x is 0, y equals 2 times 0 plus 4, y is going to equal 4. Then let's try when x is 1. Y equals 2 times 1 plus 4. 2 times 1 is 2 plus 4 is 6. So if Quentin goes on 1 walk, he gets 6 treats. Let's see what happens if he gets to go for 2 walks. So he gets 2 treats per walk times 2 walks plus 4 treats just for showing up. So he would get 8 treats in total. And let's say he has a crazy day. This would probably never happen, but let's say he goes on 10 walks. So the total treats he gets would be equal to 10 walks times 2 treats per walk plus an additional 4 treats. That doggy is getting 24 treats. That is a lot of treats. So once you have a table like this, you can put these points on the graph. Remember, another way that you've learned to write these points is like this, with the value of x first and the value of y next. So if it helped you to remember your graphing to rewrite it like this, feel free to. And then you can create your own coordinate plane and graph your own line. I already have a graph here pulled up where you can see that I've put these points on the coordinate plane. In real life, we would never go negative with this specific example because Quentin can't get negative walks per day. But there are a lot of scenarios where you could go negative. So you could also put negative values for X and maybe even get negative values for Y. Okay, there's one more part, the x-intercept. So just like the y-intercept is where the line hits the y-axis, the x-intercept is, write this down, where my line hits the x-axis. So if we look at our graph here, we know that this is the x-axis right here going from left to right. We know that we have y to the sky going up and down. So it hits the x-axis right here at -2. So you can graph that out and you can see that it hits the x-axis at -2. So the x-intercept in this problem is -2 because we do have that point that right here when x is 0, y is -2. So that point 0, -2 shows us that that's where the line is going to hit the x-axis. So those are the 5 different parts of graphing a linear equation. So you can kind of use that. This person graphed a linear equation to predict how much they were going to spend at the fair. You can use that for a lot of different situations, like how many treats my dog is going to get in a day. We're going to try another one. So I want you to pretend that this is Quentin's treats again, or you can make up your own story about the problem. But this time Quentin's going to get 5 treats to start off with, just for being alive. And then every time he goes on a walk, he's going to get a half a treat. So if X is the number of walks that he went on, and Y is the number of walks that X is the number of walks he went on, and Y is the total treats he gets, think about how you can use these 5 steps. Writing the equation, finding the y-intercept, finding the slope, finding coordinates to put on a graph and graphing them, and then finding the x-intercept. Out of those 5, I want you to see right now on your own how many of these can you do with this problem, y equals 1/2 x plus 5, okay? So I want you to pause the video, go ahead and give it a try, and then come back and check your answer. All right, welcome back. Let's give it a try. So first, we have the equation here already. Total treats Quentin has is equal to half a treat times the number of walks he goes on, half a treat per walk, plus 5 treats just for waking up in the morning. What a lucky dog. No, he doesn't really get that many treats. All right, step number 2, if we go back here, is to find the y-intercept. We know that the y-intercept is the number that we add to the end. So you multiply the number of walks, or the variable, times a number, and then you add a given number that doesn't change. So that is the y-intercept. What that means is when x is 0, y is 5. So we know on the coordinate plane that the line is going to hit y right here at 5. There's going to be a point there. Cool. All right. Next up, we've done parts 1 and 2. The third part is the slope. So the slope is the number that's being multiplied by the variable. And I will tell you later in the advanced video what the slope means. But for today, just know that the slope is how many treats Quentin's getting per walk, or how much it costs you extra for 1 ride ticket. So the slope is what you're multiplying x by. The next part would be to come up with some points for a coordinate plane, to put on a coordinate plane. So let's see, we already know that when x is 0, y is 5. Let's see what happens when x is 1. So y equals 1/2 times 1 plus 5 would be 5.5. I don't know if I'm too crazy about graphing halves. I can do it, but my graph might not look as neat as I would want it to. Let's look at what happens when I make x 2. Y equals 1/2 times 2 plus 5. Okay, so 2 walks times half a treat per walk gives me a nice even 1 treat to add to those 5 he gets every day. So that would be 7. And then I'm going to try a bigger number. I'm just going to say, what if we give Quentin 10 walks? So y is equal to 1/2 times 10 plus 5. So 1/2 times 10 is 5 plus 5 more. Y would equal to 10. So when x is 10, y is also 10. Let's think about graphing this out. Last time I modeled a graph that I made on my computer, so that's certainly one way to solve the problem. I can also make a coordinate plane here on the iPad, so, or on paper, of course. I know that x and y both go from 0 to 10, so that's going to make it pretty easy for me. I'm going to make this halfway point 5. This is going to be 10. And then again, this is the x-axis, this is the y-axis, and this is x, remember, represents the number of walks that he takes in one day. And then the y-axis represents the number of treats Quentin gets. Okay, so 0 walks here, he gets 5 treats. That's my first point. 1 walk, he gets 5.5 treats. 2 walks, he gets 7 treats. And then 10 walks, he gets 10 treats right there. So what I'm going to do is I'm just going to take the first point and the last point and connect them. And then I'm going to go back and make sure my middle points are on that line. All 4 dots should connect. So 1, this would be about 2.5. So I think 1 would be about here and should be about 5.5. So that looks accurate. And then 2 would be about here. 7 could be about here. Looks accurate. I probably would want to use some graph paper next time to really make sure that my numbers were on the line. So that's something that I can do to improve my graphs in the future. But anyways, that is a basic overview of graphing linear equations. So I hope you tried that practice problem. I'm going to give you some more practice problems to try tomorrow. You can pause the video and have a great rest of your day. If you're interested in learning some advanced math, you can stay tuned for the next slide. So 2 things I want to show you about advanced math are finding the x-intercept and what the slope means. So for what the slope means, when y is equal to 2, let's see, when y is equal to 2x, and we know the slope is 2, the slope is equal to rise over run. So what that means, if the slope is 2, and I have these marked off evenly, if my first point is right here, my second point I know is gonna, the rise is gonna go up 2, and the run is going to go over 1. So a slope of 2 means for every point you go up 2 and then you go right 1. So kind of like 1, 2, 1. And then we would do it again. 1, 2, 1. 1, 2, 1. So every time you're going up 2 spaces and to the right 1 space. So you can see when you connect those in a line that it is about twice as tall as it is wide. So the height here should be double what the width is, because every time we went right 1 space, we went up 2 spaces. So now let's try a different example. Let's say that you get y is equal to 1/5 x. So with all of these examples, I'm not doing a plus b or a plus a number. And so if there's no plus b or plus an additional number, what that means is that your graph starts at 0. So your graph goes through the origin at 0, 0 right there. Okay, so we know our first point on our graph is going to be right here. And then rise over run, it's going to go up 1, that's the rise. And then run, it's going to go 1, 2, 3, 4, 5. There's our second point. Rise 1, run 1, 2, 3, 4, 5. I could change this and I could make this have a slope of 2 over 5. Y equals 2 over 5x. Again, it's going to start at the origin of 0, 0 because I don't have plus something. But this time, it's going to go up 2 over 5. There's our next point. Up 2 over 5. And we see this with positives and negatives also. So if you have a negative slope, what that means, we do a third example. So this coordinate plane only has 2 parts. I'm now going to make it into a coordinate plane that has 4 parts. So again, we're starting at the origin because I don't have a plus whatever. But if y is equal to negative 1/2 x, we start here. Negative 1/2 x, that means that it's going to go the other way. So instead of going right, it's going to go left. So you can kind of take a guess at what that would look like and then Google it because I want to move on to finding the x-intercept. That's really advanced, so. All right, so finding the x-intercept, the way I showed you earlier was to just graph it out right here and to look at where it crosses the x-axis, and that's the easiest way to do it. The other way you can do it is to do some math to isolate x instead of isolating y. So we know that the equations are written in the format of y is equal to, let's say, 3x plus 2. And this makes it really easy because when x is 0, we know that y is equal to 2. So what we want to do is try to get x isolated by itself so that we can find the x-intercept more easily. So I'm going to start by subtracting 2 from both sides. That was messy. Okay, so I'm going to subtract 2 here. That cancels those out. And then I'm going to subtract 2 on this side. So now on the left side of the equation, we have y minus 2. And on the right side, we have 3x. Okay? So we've almost gotten x by itself. But to get x by itself, I have to divide this by 3. And I have to divide this by 3. So I get y minus 2 divided by 3 is equal to x. So if we go back to this graph, we see that the x-intercept is negative 2. If we make y 0, oh, this is a different problem. I'm so sorry. That's why it wasn't making sense. Okay, so if we make y 0, we get (0 minus 2 over 3 is equal to x. So we know that that is equal to negative 2/3. So the x-intercept is going to be negative 2/3 because basically that gives us the point on our table of negative 2/3 for x and 0 for y. So that's the advanced way to find the x-intercept. So you can try that out on your own. However, usually people find the y-intercept by making x 0 and then seeing, whatever number is left here already, and then they find the x-intercept by graphing it out. But that's a way you can use algebra to find the x-intercept. Please let me know if you have any questions. Thank you so much for joining me. Have a great rest of your day, and I will give you some more practice problems to start tomorrow. And please make sure that you go back to the problem up here and see if you can figure out with these examples and with this additional information, can you figure out any of those 5 things? What is the equation? What's the slope of the graph? How much does each ride ticket cost? How much does the main gate ticket cost? Any of those things. All right, good luck, and let me know what questions you have. Thanks for being here.